from exponentials and logs. Okay, so the very first problem, this is just going to ask you, this is an exponential form, so I've got 5 to the 4th equals 625, true statement. We're not solving anything here. We're just going to convert this to log form. Does anybody remember how to convert that, get rid of the exponential and convert that to a log? You remember doing this? Exactly. Exactly. Go ahead. What would you write? Yeah. Perfect. Perfect. Okay. So when you do exponential, the base of the exponent, that's the 5 there, just swings to the other side. That drags the 4 down on the level with the rest of the question. So you no longer have an exponent. And the 625 just kind of scooches over but stays where it's at. That's also a true statement. We're not solving anything there, and that's all you have to do. And this will be multiple choice, so you just pick that out of the multiple choice. Okay, now the next 2 problems go with the same general equation. So I'm just going to write this really quick, but this would go for 2 and 3 here. So you have this is called a general exponential. So I'm just going to write out what these mean real quick. And this would maybe change the topic, if that makes sense, based on what you're looking at. But A should be your initial amount or your starting amount, or maybe if you have a population, like how many people you start with. If you're working with money, how much money you start with. So it could be different things, but it's the initial starting value or starting amount. Now, B is going to be calculated differently depending on the question, so we'll have to read through context. But this is either your growth or decay factor. And to calculate the growth or decay factor, if you have exponential growth, and you'll just have to read the question for context if you have a situation like we do here, growth is 1 plus the rate, and if you have decay, that is 1 minus the rate. So you'll have to kind of identify from the question which type you are working with. X represents time there, and then Y would represent how much is left or how much is gained in terms of the amount once you're done with the question. Okay, so specific to this problem, I'm going to kind of try and lay this out. So it says a new car sells for $38,000, so that's going to be our initial amount, and it depreciates at 9.8% per year. Write a function that models the value of the car. Use your function to determine the value of the car after 4 years. Okay, so if it says depreciates, am I having growth or am I having decay? Decay. Depreciate means goes down in value. Now, the one thing when you do this, this has to be as a rate. Most of these questions will give you this as a percentage. So I would just take that. You can do just 9.8, divide that by 100, or you can scooch the decimal place over 2 spots. But this should be 1 minus that rate, which would be 1 minus 0.098. So if you subtract that, the actual decay factor here we want to use is going to be 0.902. The B value cannot be a negative number, but if it's decay, it's going to be some number between 0 and 1. Okay, that basically means the car holds just a little over 90% of its value. So a general model for this would be Y equals 38,000 times 0.092 to the X. We would absolutely not simplify that in any way, because you can't multiply the 38,000 times the 0.902, because in our order of operations, we'd have to perform the exponent first. So you don't put those 2 numbers together. That's something people will do on accident. They're just 2 separate things. Only the 0.902 is being taken to the power. So this would be my model. All right, now it says find the value of the car after 4 years. So in that equation, X is time. So all we're going to do to answer the rest of the question is plug in 4 for X, and this is where I would just grab my calculator. All right, so 38,000. You guys will have your calculator for the entire exam here. So to the 4th power, use my little caret button. And if I'm talking about money, I'm just going to go to the nearest hundredth. So $25,154.16 if I'm looking at that. Anybody have a question? Okay, now, same information, but different problem. So I'm still gonna look at that. I'm gonna leave that up on the screen so you guys can see the general equation. It says the house is purchased for $225,000. So that's gonna be my A value, my initial amount, and appreciates in value 6.3%. So if I appreciate in value, am I doing exponential growth or decay? Growth, right? Okay, so B value here is going to be 1 plus 0.063. So 1.063 would be what I want to put in. That's my growth factor. All right, so the general equation, if they ask you for that, 225,000 times 1.063 to the x. That's a general model because it's got an x and a y. And then it says use this to determine how much the house is worth after 10 years. So we're just going to plug in 10 for x, and then we'll figure that out real quick. So I'm going to do 225,000 times 1.063 to the 10th. So $414,491 and about 6 cents if I round that to the nearest hundredth for money. Is anybody having a question? Bless you. All right, now there is one problem like what I have in number 4, but I just put a couple examples here. So it'll say if the annual rate of change is, and they'll give you one of these amounts, find the corresponding growth or decay factor. This is really similar to what I just did, just finding the B value is all it is, but I just gave some different percentages here. So if this is adding, so this is adding 45% or increasing, that's trying to indicate growth. This would be 1 plus the rate. If you have a negative, then that's going to be 1 minus the rate. If I'm adding the rate, that's a growth factor. If I'm subtracting the rate, that's a decay factor. So just the plus and the minus will indicate that to you. Now, for that very first problem, just says 45%. You got to change that to a decimal real quick. What would be 45% as a decimal? 0.45. So all I would do here, this would be 1.45 would be my growth factor. And the question will specify that. It'll say, is it growth factor or decay factor? So this one would be growth. If you have a negative, this is negative 30%, this would be a decay factor, what I'm going to calculate here. So this one is 30% decay, so it's going to be 1 minus 0.3. This would be like if I had 100% on a test, I took 30% away, you would get a 70%. And you don't need the 0 there, but I'm just going to put it on mine. Now, if I do plus 320, this is kind of weird. I'm going to do, if I'm adding my rate here, I'm going to add this because it's plus. How would you write 320% as a decimal?
3.2.
Good. Okay. So this would be 3.2. So then if I add this up, this would be 4.2, and this would be the, since it's a plus, this would be the growth factor. If you're increasing something by 320%, you're more than tripling it. And I just spelled the word factor wrong, fail. Okay. Now, if you have a single digit, like this is just minus 7%, don't forget this is 0.07 as a decimal. So if I'm taking that away, it's 1 minus 0.07. So like if you had 100% on a test and I took 7% away, then you would still get a 93. So just wanted to put that on there. That would be decay factor there because we're going down from 1. All right, and I'm going to use the same equation for this question. So you're going to get a problem. They're going to give you 2 points, and they're going to say write an exponential function, and they will literally type that right into the problem. And it's been a minute since we've done this, but we're going to make a system out of this. What I would always recommend to you, start with whichever point has the bigger x value. It'll make the algebra way easier to do. So just look at the 2 points they're going to give you. And my two x values, I've got 1 and I've got 3. So the bigger x value is obviously the 3. What you do with those 2 points, we're going to just use these as x and y, and that y equals ab to the x equation. So I'm going to start with this one. So in place of y, I'm going to put 44, and then AB, and in place of x, you put 3. Because I know x and y, because I've got these two coordinates, I'm trying to figure out a and b to get this relationship. Repeat the process with the other point. So I'm going to do 11 equals AB to the first. Okay, now this is a system. You guys typically, when we do systems like linear systems, we add or subtract the bottom line and the top line. If you get an exponential model, easiest way to do this, I'm going to divide the top line by the bottom line. The reason you do that, if you set this up, every single time you just have a plane A and a plane A in each of these. If you divide that, that just becomes 1, and that eliminates that variable. Okay, now, the reason I'm asking you to put the bigger x value on top is when you divide there, that's going to make that easier to work with those exponents. So for the numbers here, this is just real quick. 44 divided by 11 is just 4. Now, I'm using exponent properties here. What would b to the third divided by b to the first become if I divided that? B squared. There you go. That's right. It's if I put the 1 on the top and the 3 on the bottom, then I'm working with a negative exponent, and that's annoying. So just put the bigger x value on the top, make it easier to do. Now, when you guys do this, you can take a square root. And normally when we take a square root, we put a plus and minus. But if you are working with an exponential model, you are not allowed, it's not defined for a b value to be negative. So you do not put a plus and minus in front of this. We're just going to use positive 2. Once you got that value, you're good to go. We're just going to plug this back into either one of the equations to get a, because I need both of those guys. I'm just going to plug it into the one at the bottom. So I've got 11 equals a. Now I know b is 2, so a times b to the first. So this would be 11 equals just a times 2. 2 to the first power is just 2. And I know this isn't the greatest number in the world, but this is how it is on the final. So I set it up like this. It's going to be a decimal, but it's going to be kind of a decent decimal like what I just got there. Now, what you would want to look for in your multiple choice, we'd want to have that format, y equals ab to the x. A is 5.5, b is 2. You do not multiply those together, you keep them separate, and the exponent on the 2 would be the x for the general model. Anybody have a question? Okay, these ones at the bottom, this might be where that lovely little yellow paper might come in handy if you guys still have that. If you don't, I'm going to give you another copy of it. I should have printed them yesterday and I just didn't. But if I have to evaluate the logarithm, what I would just recommend, I'm just going to set each one of these equal to x really quick. There'll be one question like this, and I know I put some extra practice on here, just a couple of these to remind you some properties of logs as we're going through. What you want to do, get rid of the log, and that's why I set this equal to x to give me somewhere to swing this. I'm going to swing this 2 across here, and I'm going to rewrite that in an exponential form to get rid of the logarithm. So the base of the log becomes base of the exponent. I'm just going to push that x up in the air. Now, can you think of 8 would be 2 to what power? 3, and that's your answer, and there we're done. That's it. That's all you have to do. This one I put on here, if I just have a plain log, no subscript, what is the subscript? Do you guys remember? 10. Okay, so I always for myself, I put that in there. So I'm just going to swing this 10 to get rid of the log. So I have 10,000 equals 10 to the x. Okay, 10,000 is 10 to what power? 4. However many zeros, that's the exponent. So there's 4 zeros, this is 10 to the 4th. Okay. If I swing this one, I'm going to get negative 25 equals 5 to the x. What are you going to write for that question? That'd be 1 over 25. Okay. Can I take the log of a negative number? No. Yeah, I put this one on here. Okay. This is no solution. There is no number I could plug in for x that would ever make that true. If I probably shouldn't have even converted that. You cannot take the log of a negative number. It's not possible. It's not defined. So I probably wouldn't have even converted that to exponential. If I was doing that, I would have been just like, nope, we can't take the log of a negative. So don't forget that. Not defined. Can't take the log of a negative. All right, and I've got one more. This one's probably the trickiest of them all. All right, so I'm going to get rid of my log by converting this to an exponential. I got 1 over 81 is going to stay where it's at. Base of that log is going to push that x up in the air. So 1 over 81 equals 3 to the x. Does anybody remember, like 81 is 3 to a power. Does anybody know what power 81 is for 3?
It's to the fourth.
To the fourth. Okay, so what if I have 1 over 81, how could I write that as 3 to a power?
3 to the negative.
There you go. Fraction means negative exponent. This is just 3 to the negative fourth. So then the actual answer there would be negative 4. Is anybody having a question? Okay. Flip this over to the back. Okay, now I know we spend a lot of time, we would have a log written out in a couple different pieces and then we would squish it together and write it in a single log. The one on the final is going to give you a single log and ask you to do an expansion. So I just want to remind you of these properties real quick. Okay, and I'm going to do this one in 2 steps. So if I'm multiplying 2 things together, I have 2 times x to the 6. What you do for your log properties, if you got to expand it or break it apart, multiplication reverses into being addition. So this would be log base 6 of 2 and then log base 6 of x to the 6. That's undoing what they call the product rule. So I could squish that back together with multiplication. Now, you don't have to do this in 2 different steps, but I'm going to do this just to show you for this first one. There's another rule, it's called the power rule. If you are taking the log of something that has an exponent, you are allowed to bring that down in front and multiply that in front of the logarithm. It's called the power rule. So completely expanded here, this would be log base 6 of 2 plus 6 times log base 6 of x. And I think some of these might maybe be a little bit less work for you when you have multiple choice options. The entire final is going to be multiple choice, so just keep that in mind. Okay, another little review concept. So let me rewrite this really quickly. Can anybody tell me another, if I have the square root of x on the top there, how could I write that as x to a power? So like instead of a square root, x to the what power? Remember? 1/2, there you go. Okay, so now if last one we had a product, this one we have a quotient. So if you are dividing, if I'm going to expand this logarithm, I'm going to subtract in between these two. Whatever's on top goes first, and I'm just going to go ahead and apply that power rule as I go here. So that first term I'm going to write down 1/2 times the log of x, and then I'm dividing that by y to the third. So if you're dividing, that turns into subtraction if you're expanding the log and breaking it apart. So this would be minus 3 log of y. That one doesn't have a subscript, so it would be base 10, but you do not need to write that in there. Okay. Now, I've got log base 7, x squared minus 5, log base 7, x plus 1. Nothing else added or subtracted. So what I'm going to do here, if they're both base 7, which they are, we are literally just going to set these two lovely things equal to each other. Okay, so just drop the logs. If they're both base 7, they're both equal, nothing added or subtracted to the side there, just direct. This is just going to be x squared minus 5 equals x plus 1. Okay, now what's going to happen here? We're going to end up with a quadratic because I have an x squared and an x, and nothing's going to cancel either one of those terms. So what I would do is I'm going to set this equal to 0. So I'm going to subtract x and I'm going to subtract 1 to the other side. I'm going to try and keep my squared term positive. If you do that, you're going to get x squared minus x, because it was positive x on that right side, so if I move it to the other side, I got to subtract it. And then the only thing you can actually combine here, you have a negative 5, and I'm going to subtract that 1, so that's going to be negative 6. Okay, now you all can use quadratic formula if you want to, but I might tell you it'd be faster to just factor this real quick if you can think of them. Can you think of two numbers would multiply to give you negative 6? The same two numbers would add to give you negative 1. 3 and 2. To get the negative, it has to be negative 3 and positive 2. Okay, actual answers to the question then would be 3 -2. Okay, now see in the directions it says check for extraneous solutions. Are either one of those extraneous solutions, or are either one of those going to cause me a problem?
-2 could,
Why?
because the negative.
Right, but what about the negative? Is it going to cause me to take the log of a negative?
Oh, you can't take it all.
That's right, yes. Okay, so answer here, and I'm writing this out, and I'll explain myself in a second. The answer here is just 3. The extra answer is -2, and the reason is I can't take the log of a negative. You got to remember that. That's what can give you a possible extraneous solution here. Now, if I do that, if I plugged in -2, if I squared that, that'd be 4, but then I'm subtracting 5. So that's causing me to take the log of a negative. It would also cause me to take the log of a negative on the other side. It really only needs to mess up one of them. The question on the actual exam is going to give you a problem like this, and then it's going to literally say, what is the extraneous solution? So the answer to this question is 3. That would actually work. The extraneous solution there would be the -2, because that causes me to take the log of a negative number. Okay. Does anybody have a question? All right, these next two I'm going to do in a little bit of a kind of a weird way, because the way it is on the actual final, they don't actually get a number for either one of these answers. They kind of leave all the steps in the multiple choice. I'm going to show you what I mean in a second. Okay, so I've got 2 equations. Number 10 has a natural log. Does anybody remember the little subscript for the natural log? It's log base e. Good. Okay, so I usually just put a little e in there because it's not going to be typed in the question. But the natural log is just a log base e, so I'm just going to put the little subscript in there. Okay, if I'm trying to solve this equation, what would you do there? So what would that look like? Perfect, perfect. You're going to get rid of your natural log, and we're just going to leave this 2x minus 9 on this side. That e is going to push that 6 up in the air. And remember, e's got its own little button on the calculator, so we could evaluate this, but we're not going to, just because I wanted you to leave it in this format. Okay, after you move that, then what would you do if you're trying to get x by itself? I got 2x minus 9 equals e to the 6. What would you do next? Add 9. Okay, so then I'd have 2x equals e to the 6 plus 9. And then I would need to get the x by itself, so I'm going to divide by 2. Now, I know you guys could type this in your calculator, but the way it is on the actual exam, the multiple choice is going to leave it as an exact answer in that format. So I'm just going to leave that alone, so just keep that in mind. The actual question on the test leaves it like this, just so it's not confusing. I know we could go through and get an answer. Actual question's going to leave it in that format. Okay, so that was the natural log equation. Now I got an exponential equation next to this, and this is going to be similar. I'm going to kind of write my answer in a weird way for this question. So I've got 5 times 8 to the 3x equals 45. What would you do first there? Divide by 5. Do not multiply that 5 and that 8 together. All right, so I've got 8 to the 3x, 45 divided by 5, that's a nice number, that's 9. Okay, what do I do next then? I've got 8 to the 3x, my exponent is where the variable's at. What do you mean by carry the 8 over?
Like, come on, log.
There you go. Yep. This exponential, we're just going to change it to a log. So base of the exponent, we're going to come over here. That drags the 3 down on the level with the rest of the question, right? The base of the exponent, which is the 8, becomes the little subscript for the log. Okay. Now, I know some of you guys have, if you have an 84, you have that nice button on your calculator that'll do that for you. The way the test does this is going to use the change of base. And if you have an 83 or an 84, you can do the change of base. So the way this is going to lay out, they changed this to base 10. So we could type it into the calculator. To do that, you just have the log, base 10, I'm just going to write log, of whatever you're taking the log of divided by the log of the subscript. That's called the change of base. And that way anybody could do it whether you had an 83 or whether you had an 84. And that would be equal to 3x. Now, I could divide both sides by 3 or multiply both sides by 1/3, but I know this is super weird. This is how the answer is left on the final in the multiple choice. It's in that format. So it's having you do the change of base, and it's just trying to save you some time so you don't have to go through and divide by 3 and round and all that kind of stuff. So it'll be left, and it will be left with like the 3x, whatever the exponent was. I don't think it's 3x, it's something else. But it'll be left in this format. So when you do the change of base, just remember, it's the log of whatever you're taking the log of, that goes on the top, and then the log of the subscript goes in the bottom. That's going to be base 10. That allows you to do that on your calculator. All right. Now, these next two, super similar, but two different equations that we got when we were talking about compounded interest. All right, so I'm going to give you the formula here real quick. So amount in your account, this says you invest $3,500 in a CD at a bank that compounds interest monthly. Okay, so there's two different formulas, and which one I would pick is going to depend on how often they compound their interest. So if I compound monthly, that is one of the formulas that we had, and it looks like this. Principal, and then 1 plus your interest rate divided by the number of times you compound during the year, and the exponent, number of times you compound during the year, multiplied by the time. Okay, now, if I compound interest monthly, how many times a year would I get interest applied? 12. Okay, so N here is going to be 12. The interest rate is 6.5%. You have to change that to a decimal, so 0.065. Your principal is your initial investment. That's your $3,500. And the time here is 6 years. And we're literally, once you have this, you're just going to plug the whole thing into your calculator. You don't have to do anything. We're not going to do a log or anything like that. So for this particular question, we would have 3,500. And then 1 plus 0.065 over 12. That number of times compounded goes in twice. So we're going to put that under that 0.065. And then the exponent is number of times compounded multiplied by how long it's in the bank. Okay, the only thing I would say to you, if you have an 83, you're just going to have to either figure out what that exponent is or put that in parentheses either way. If you have an 84, you'll be able to see the exponent. So I'm literally just typing this exactly as it appears in my calculator. It should do it for you, no problem. Whoops. If you have an 83, just when you do the exponent, just put parentheses around it. If you have an 84, you can see that I'm doing the 12 times 6 all in the exponent. But if you have an 83, just put parentheses around it. And then this will tell you the amount after 6 years. And because it's money, I'm going to round to the nearest, this actually round up to the next dollar. So $5,164 even. So that's your compound interest formula if it gives you monthly, weekly, daily, something like that, a specific amount of time. The other formula we're going to use in number 13 here. So it says you invested $6,000, that's going to be your principal, at annual interest rate 4.25%, so 0.0425. Now, this is where I'm going to get a different formula. If you have compounded continuously, I want you to think of E. And how much will we have after 7 years? So continuously compounded interest is what we call the PERT formula. And it involves E, like your natural log base. And that's not a variable, that's that 2.7818. It's got its own decimal. So this one's actually a little bit less work because there's less to plug in. You're just going to plug in the principal, the rate, and the time here. So for this question, sorry, I'm going to sneeze. All right, so 6,000 E. To get the E button, you're going to hit second and natural log to get to that. Your exponent 0.0425 multiplied by the time, which is 7 years. Now, if you have an 83, I think it automatically will pop up a set of parentheses if you use the E button. I'm going to type 6,000, and it should just be the natural log key, and whether that's scientific or graphing, it's probably the second function on there. It's right next to the for key, but I have to hit second natural log to get my e to the x. So I'm going to hit second natural log, and then in my exponent, 0.0425 times 7, and then I'm going to hit equals, and that's going to tell me how much money. So $8,078.93. A lot of these questions you can just type into the calculator. It's just a matter of knowing which formula you want to use. Okay, the last one on this page real quick, and I got a couple more in the back, but they'll take really, really small amount of time because they're going to be little graph questions. All right, the half-life formula is a slightly different modification of a general exponential. I'm going to have y equals a. If you're working with half-life, you're going to take half away every time. So that's got a decay factor. It'll be 0.5. So we're going to take 50% away anytime you have a half-life. So I always know the b value. The only thing that's majorly different for general exponential and half-life is the exponent here. So it is x over, x would be time, whatever the half-life is for the substance. So it's just a little bit different than a general exponential, and that major difference is in your exponent there. X is time, half-life, and the time have to be the same units. So this says the half-life of acetaminophen, which is just Tylenol, is approximately 2.5 hours. Thank you. And it says if you take 325 milligrams for a headache, how much will be left in your system after 8 hours? Okay, so your initial amount is 325 milligrams. That's just a normal dose. And 0.5 right there. How much would be left in your system after 8 hours? Well, what you need to do for your exponent is 8 divided by the half-life. So 8 divided by 2.5. All right, now again, if you have an 83, I would just put that exponent in parentheses. If you have an 84, you'll be able to see the exponent. So I'm going to do 8 divided by 2.5 here. And I'm going to go just a couple decimal places. So we'll say 35.37 milligrams still in your system of the Tylenol after about 8 hours. Anybody, I just got a couple more questions. I know I didn't have a third page yesterday. There's more questions on this section on it. Lovely test. Okay.
What was the answer?
Sorry. 35.37 milligrams left if you type that in.
I didn't even get that.
Would you, let me
I
see.
got 186.
You're good. Okay. Anybody else have any questions? Now, this is super fast. So I just need you to describe to me what's going on in the equation, like how it would shift the graph. Okay, so just graphed in the picture there, it's just a log base 2 of x, so just a general graph there. And it's saying if I change the equation, how would that shift the graph? That's all I'm asking you, so like left, right, up, down. All right, so inside with the x, that's going to move the opposite way you think, and with the x goes left or right. So if this is x, that looks like a -5 to me, so it actually goes 5 units to the right. That's all I'm looking for there. Outside the log, or actually this works for any type of a function. Okay, so outside of that operation with the x, I've got a +7. So that just is going to shift the graph up or down exactly like opposite copy. So up or down is going to be outside whatever you have. If you look underneath here for letter B, this is x -5 again. So this would be 5 right. -7 on the outside would shift the graph down 7 units. So 7 down for this one. I just put every possible combination you could have. If you have x +5, to me that looks like a positive. So with the x goes the opposite way you think. This is going to be left 5 +7 is up 7. If I have a +5 again, that's left 5, -7 on the outside of the operation, down 7. That's all I'm looking for, just a little description there. Now, these will be a multiple choice question on the final, and I can't remember, it's like which one is growth or which one is decay. So I'm just gonna have you guys label these as growth, decay, or neither to see if you remember. So just no work or anything like that. This first graph, would you label that as exponential growth, decay, or neither? This is neither. I know this is, and that's why I put this on here. So a lot of times people think decay, but no. If it points down, neither. It's an exponential function, but it's not growth or decay. It's basically a flipped over version. Now, what about this one in the middle? This one is decay. This decay for an exponential model starts big and it goes down as you go, as time passes, okay? And then the last one then is growth. Growth goes up from left to right. But if you have growth or decay, they have to point up. If it's decay, it points up on the left and down to the right. And if it's growth, it points, or it's kind of like down on the left and it goes up as you go to the right. Okay, now, really, this is actually kind of related to 15, but an exponential instead of a log. So I'm going to rewrite this equation with this information. So what I have on the graph, y equals 4 to the x. Okay, so I'm going to shift that left 3 units and up 2 units. How would I write that into my equation? So that's what I'm going to do real quick here. So left or right is going to go with the x. So this is 4 to the x. So it says x 3 units to the left. So opposite of what I think, so it's actually going to be x plus 3. That would actually shift the graph 3 units to the left, all that up in the exponent. If you want to go up or down, that's just going to be to the side of the operation, so back down on the level with the rest of the question. Up 2 would just be a plus 2 to the side. So that would shift everything in the graph up 2 spots. The next one says just shift it down 5. So don't change anything for left and right, so that's just going to be 4 to the x. If I want to shift this graph down 5 units, up or down, it's going to be outside that operation, exactly what you think. So this says 5 units down, so I would just have minus 5. And then I'm going to finish this last one and we'll be done. Now, this graph, as it's pictured here, has an asymptote, y equals 0, the x-axis. Nice horizontal line. We get really close to that, never touch it, never go over it. This one says I want to shift the graph 2 units right, and I want it to have a horizontal, so same direction, horizontal asymptote at 7. So if I have a horizontal asymptote at 7, what that's saying is this would go up to 7. So really what this information is saying to me is saying up 7. That's really what that's saying. So to write that, I got to go 2 to the right, so it'd be x minus 2, opposite of what you think when you're moving left or right, and that goes with the x. And then because I've got this asymptote going to be at y equals 7, we're going to go up 7, so I would have plus 7 to the side. Is anybody having a question?